Hello, dear friend. We will solve our midterm exam question. Here's the first question, and first case of that question we will write. Okay, let's write the title, the midterm discrete mathematics midterm exam solution. So question 1 and here and solution. So first one, case A is case A questioning A complete intersect B is equal, and to solve that one we need to know as a complement B, we need to know A complement, then we will look for the intersection between A complement B. So let's find the A complement is equal. So we are looking for actually what is the member of the set A. It is the 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So complement of A will be written according to universal set. So we will write here as a 1, 2, 3, and 7, 8, and then 9 is belong to set A, and 10 to till 18, and I will write here as a 19, 20, 21, and 28, 9, and 30 is the complement of set A. So if we are looking for the intersection complement of A and B, so what is the inside of the B? So there is the 14, and when I look here, there is no 14, so I can take 14 and 15, no 16, and no 17, 18, and then as you see inside of the B and complement there is 19, and there is also 20 for both set, and 21, yes, and 22 also as a last member of that case as a solution, case A and case B. So what we have for case B, we look for C difference B, right? C difference B, or we can say C difference C and B, or C minus B. Okay, let's write the set C, and there is the 10, 12, 14, and 16, 18, and 18, 20, 22, 4, and minus set B. So what I have in set B, 14, 15, 16, 17, and 18, 19, 20, 21, 22. That's it. So let's do minus, I'll minus 14 from here. Okay, 14 and 15. There is no 15. 16 and 17. There is no 17. 18, 19, 20, 21. There's no 21. 22. And as a rest, I have here the what? C difference C minus B. I have here, so I have a rest in C as a 10, 12, and 24 is my solution, case B. And case C, okay, let's look at that solution as a what I need C, set C, union D, and in parentheses there is the symmetric difference A is my question. And to make it easy for that question, I have to write as a union C D. So what I have in C, there is the 10, 12, 14, 16, 18, 20, 22, 24, and in D there is the 21, 3, 25, 7, and 29. So this is the my C and D union set. So what I have in A, okay, let's write the A. I have in A 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So I will raise the common element of that two set as a C union D and A. What I have as a common term, 10 is here, and 10, 11, no, 12, and 14, and there's no 15 and 16. There's no 17 and 18. You see, I have those as a member. I will write rest of my members as a solution 9 and 11 and 15. 11, 15. Yes, right? No, 13 and 15 and 17 and 8. No, 18. I erased that one, and 20, 22, 24, 24, and 21, and 23, and 25, 7, and 29. This is my solution. And if you make, less than greater, you can change the members as a place 20, 21, 22, 23, 4, and 25, something like that. This is gonna be your answer or solution. And D, A difference D, let's write the A. Set A is the 9, 10, 11, 12, 13, 14, 15, 16, and 17, and 18. Difference D, what I have inside of the D as a 21, 23, 25, 7, and 9. So is equal, let's write the is equal, and I have as a 21. Is there any 21? No. 23? No. And 25? No. 7? No. 29? No. This is gonna be is equal as A. So I do not write to set A again. Can continue with the E. I'm sorry. A, B, C. Oh, I jumped D. This is the E. So let's write the D here. Okay, D. I will write B union C as a complement, and let's write the B and C set here, and then I will take the complement of that set. What is the B? There's the and C. Okay, 14. We can start with the smaller one as a 10. Okay, inside C. Okay, 12 again C. Okay, 14 inside B, 15 inside B, and 16 for both, and 17 inside B, 17, 18 for both, and 19 from set B, 20, 21, 22, and 24. This is my union B and C. Then I need the complement of that one. So what is my complement? I mean, for that set, it is going to be start with the 1, 2, 3, and 7, 8, 9, 10 is here, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. Okay, I need to write here as a 23, and then 24, 25, 26. So 29, okay, 29 and 30. This is my answer as a D, A, B, C, D, and E. What is the next as a F? Okay, F, B, symmetric difference. D, okay, I will write the set B. So what is the B? 14, 15, 16, 17, 18, 19, 20, 21, 22, and 22, symmetric difference. So what is inside of the D? 21, 3, 5, 7, and 29. So symmetric difference means if there is the common element, I'm gonna erase that one and I will take the rest. 21 is here. I will erase from the both as the 21 and 23. 23. No, there is no 23. So this is my solution. Right? I have here as a 14, 15, 16, 17, 18, 19, 20, 22, 23, 25, 7, and 29. Okay, this is the solution of question 1. So let's continue with the second one. Okay, second question. Find the elements of sets and write which sets are equal and which sets are contains or subset to each other. So we will solve that one. So what we have as a set. Okay, question as a solution 2. Second question. Okay, what we have as a set A, in set A, I put here as a, A, there is the x, which is x to the power 3 minus 8, 8 times x squared plus 20, x minus 16 is equal 0. So which means that we have, actually we need a solution of that equation. Then we will have root of the that equation. Then we will say, okay, this is the x value in that set. Then we will look for our solution. Okay, 20 times x minus 16 is equal 0. So root of equation, and there is the x minus 2 has a power, in parentheses, power 2 times x minus 4 is equal 0. So it means we have x1 and x2 is equal 2. There is the x3 is equal 4. So it means A has 2 times 2 and 4. If you write the only, sets without repeated members as a 2 and 4. So this is the A. And B, we have set B. Again, same procedure. There is the x to the power 3 minus 6 times x squared plus 11 times x minus 6 is equal 0. So again, root of equation. In that system, there is the x minus 1 times x minus 2 times x minus 3. So this is equal 0. So it means we have x1 is equal 1, x2 is equal 2, x3 is equal 3. So B has the member as a 1, 2, and 3. And what is the next? A, B, and C. Okay, C. C is natural number and less than is equal 5. So it means 1 in the set C, 2, 3, 4, and 5. So we do not think about more. This is the set C. And D, D also similar like the A and B. So we have to look for the root of the system. So there is the x, again, x to the power 3 minus 12 x squared plus 44x minus 48 is equal 0. So root of the equation, so there is what? And there is x minus 2 times x minus 4 times x minus 6 is equal 0. So there is the x1 is equal 2, x2 is equal 4, x3 is equal 6. So D has member as a 2, 4, and 6. So what is the next? So this is the D, and we know the E, A, B, C, D, E. Okay, there is the E. I don't want to confuse my mind. I will write the left side of the page. E, 1, 2, and 3. And F is equal 2, 4, 6, and 8. And G is equal 1, 2, 3, 4, and 5. And last one is H, and 2, 4. So I have all set is here, and A is 2 and a 4, and B 1, 2, 3, and C 1, 2, 3, 4, 5, and D is a 2, 4, and 6, and E 1, 2, 3. Like what? 1, 2, 3, like B, and F 2, 4, 6, 8, and G again 1, 2, 3, 4, 5, and so on. What is the relation on those sets? If we have a place, I will try to write here our relation. Okay, A is equal 8, right? So this is 2 and 4 for both sets has the same element. And BE also, B and E is equal to each other. 1, 2, and 3. Okay, BE. And is there any equal? Yeah. There's the G and C. 1, 2, 3, 4, and 5. Okay. There is any equalities 2, 4, 6. For D, there is no equalities for D. And what else? So these are the equalities in question 2. These are the equalities, and contains or subset relation. Of course, there is, and we can see here, G contains the B, right? Or B is the subset of the G and C for both B and E, right? Okay, is there something 2, 4, 6, and D also contains A or H, right? A or H contains by D, and there is also relation with the F. F also, covering or contains A and D. Okay, F. I know A is equal also H. H you can put here as a H for the same relations. And there is also B is subset of G or C. Is there any more? No. We know G is equal C, and we have totally 6 heads and 2 A, B, C, D, E, F, G, and H. Now we wrote all relation, I think. That's it. Okay, this is solution 2. And let's look at the solution 3. Okay, let's change the question. 3. Okay, let's take the 3 as a here. Okay, we have question 3. So there is the relation RF, G, and question is write the R, and okay, let's start relation matrix with the R and solution 3. So for relation matrix of R is equal as a row 1, 2, 3, 4, and 5. And there is the A, B, C, D, and E as a column. So what I have here is a R1 relation with the 1A here. 1A means I will put here as a 1. 1B, and there is no, 1 to that column member as a 0 as a rest, and 2b1, there is no 2 goes to any member of what is this set B, and 3 goes to C. There is a relation with it from 3 to C. I have 1 here, 3 to E, 1, and there is nothing more with starting 3 in relation 4A and 4E, 4A and 4E, 0, 0, 0, 5A, 5B, 0, 0, and 5E. This is my relation matrix of R, and I have relation matrix of F. Let's find the F relation matrix. It is from relation matrix F from B to C. Okay, B to C. I have A, B, C, D, E, A, B, C, D, and E. And here is what I have: X, Y, 5 member, right? X, Y, Z, T, S, yes. Y, X, Y, Z, T, and S. Okay. So from A to X, 1, A to Y, 1, A to Z, 1, and there is nothing with starting A, and B, Z, E, S, B, Z, and B, S, and 0. Rest of that row, C, T, only 1, there is the C from to T, from C to T, 0, 0, 0, and 0, and D, and from D to S, okay, from D to S, and D to T, 1 and 1, we have only 2D, okay, I wrote them, and EY and ES, EY and ES, 0, 0, 0. So this is the matrix of F. Okay, let's write. Let's write. Okay, anyway, you can make like that. Okay, to see question, this is the easy way. And let's write the matrix of RF. I need to write G, right? I need to write G also. Then that's it. Okay, let's write the matrix G. Matrix G is equal from X, Y, Z, T, S, X, Y, Z, T, S as a row, and column 1, 2, 3, 4, and 5. For G, from X to 1, X to 1, X to 3, X to 4, and 0, 0. And Y to 1, Y to 2, Y to, there is no Y, there's 0, 0, 0. And Z goes to 3 as a 1, and 5 is here. and 0, 0, 0, and t goes to 1, and 1, 2, and there is 0, and for s, 2, and 3. That's it. I wrote that one. Next one is a matrix of composition relation matrix from R to F. So it means 1, 2, 3, 4, 5, X, Y, Z, T, S. 1, okay, 3, 2, 1, 4, 5. And here X, Y, Z, T, and S. So what I'm going to do here, I'm starting with the 1 as a relation R, or I can do multiplication, but I will take as a 1 for each, addition if there is more than 1. For example, if I take that column to multiply with that row, I will get here as a 1, right? If I take the second column, multiply here again, I will have here as a 1. And then third column, multiply with the first row of the relation matrix R. Okay, third one, 1, 1, 1, 1. It's going to be 2, but I will write here as a 1. And third one, fourth one, and there is the 0, 0. It's going to be 0, and rest of the row as a 0. Here is 0, and 0, 1. It's going to make 1, rest of 0, and I have here as a 1. I'm going to repeat that calculation as a matrix multiplication. It is kind of matrix multiplication. Or you can do what? You can do look for the relation here. I completed 1 for 1a, 1b, and there is the 2. 2 goes to b, and I'm look for here as a b goes to z and s. So from 2 z to s. So 2 z and 2 s is my answer actually. Or you can continue multiplication matrix method. Both for correct, whatever you want, you can write it. And then third row here, first column multiply third row is gonna be 0, and then second one is 1. The second one multiply here 1, 0, 0, 0, 0, 1, and here is gonna be 1, right? Okay, 1, and next one 1, 1, 0, 0, 0, 1, 1, 0, 0, 0 is here 0, and next one 0, 0, 0, 0, 1, 1, 1, 0, and here is gonna be again 1, and last one 0, 1, 0, 0, 0, 1, 0, and 1 and 1. And next one is a fourth column. Fourth row of the composition relation matrix R to F. I will take, again, first column from here, then multiply here, 1, 1, and rest is 0. Here is gonna be 1, and 1 starting with the here 1 and 1. I will write here 1 and 1 and 1, 1 and 0 and 0 and 1. So next one, and for the last row, I will take again here as a multiplication with the last row of the relation matrix R. 1, 1, 1, again 1. So I won't check rest, just there is the 1, that's enough, and 1, and see, is there any matching for ones? No, here is the 0, and last one 0, 1, yes, there is the 1. So this is my composition relation matrix from R to F. So next one is a F to G. So from F to G, it means A, B, C. F to G, and then here 1, 2, 3, 4, and 5. So F to G, I will multiply first column here as a 1, and second one again 1, and third one 1, and 1. I want that one as a 1. So this is the F or G as a first row, and again G to F, take the first column multiply the second row of the F relation matrix of F, and 1, 1, 0, 0, 1, 0, and 0 here, and second one 1, 1. I will take 1, I won't check the rest, and third one 1, 1, and next one 0, 0, 1, 1, 0, here is 0, and last one 0, 1, it's gonna be 1. Okay, here multiply I did something wrong. Okay, I'm gonna repeat G to F again. First column multiply with the first, I'm sorry, first column, second row, 1, 1, 0, okay, 0, and that one I'm gonna repeat to make sure 1, and that one has a column 1, 0, 1, 0, 1, 1, and that one is 0, and next one is 1. Yeah, this is correct. And C, multiply with that column the third row of here, and here only 1, 1, so here is 1, and second one 0, 1, 0, 1, 1, and third one 1, 0, 1, 0, and 1 is here, again 0, and 0, and 0. And next one as a G multiply with D and that row, and here's the last two member is 1 multiply with here and 1, it means 1 is here, and 1 is here, and 1 is here, 0 and 0. And last one, I have 1 is here and here, and second one, matching that one as a 1, and 1, and here is 1, and that one has a 0. I'm trying to make sure, and 0. Okay, this is my composition matrix, and next one is a composition matrix G to R. So I have here as a Z I X T S. So it's here as A, B, C, D, and E column side. So from R to G, so I will multiply that one, and here as a 1, first one. I will take that column, multiply that row. It is going to produce 1. Okay, 1. And here again 1. And 1. And last one is 0. Okay, 1. Okay, let's make sure again. I will use that one. And R to G, R to G, okay, R to G, and multiply with that column, in that row. So it is going to produce 1, and that one 1, and next one is going to produce 1, and here is 0, and last one again 1 as a G relation, composition relation G to R. So again here, first column with the second row produce 1, second column with second row 1, third one 0 0 1, here is the 0 and 0, and next one is again 0. Okay, next one, okay, next one is a third row 1 0 0 1 1, here is the 1, and 1 1 0 0 1 and 1, and 0 0 1 and 1, and 0, and next one there is the 1, and next row 1 0 1 0 0 1 1, 1 0 0 1 1, and here is the 1 1 1 and 1, and 0 0 1 0 0 0, and 0 0 0 0 0 0 0 1 1, here is again 0, and last row 1 0 0 1 1 0 1 1 1 1 1. Okay, next one 0 0 0 0 1 1 1, and 0, 0, 0, 0, 0, 1, 1, 1, and 1. So this is the composition G2R relation matrix, composition relation matrix G2R, and I will write directly a composition matrix multiplication with the composite matrix relation matrix R F, and I will multiply that to R and F, and here actually RF, okay, here, but I don't remember what is the, more than one. Okay, take again the first column, multiply here as a 1 and 1, 1 and 1 and 1, 1, 0, 0, 2, 0, 0, 0 and 0, 1, 0, 1. It's going to produce only 1. So this is the first and first row. Okay, I don't need the maybe question anymore. Okay, second row, 1, 0, and again 0, and 1, 1, 0, 0, 0, and 0, 1, 1, and here is 0, 1, 0, and 1, 0, 1, 0, 1, 0, and 1 again, and fourth row, 1, 1, okay, 1 and 1 as a 2, 1, 0, 1, and 0, and 1. The last row, 1, 1, 1, 2, 1, 1. It's gonna be 2 again. Okay, 0, 0, 1, 1, 0, 0, 0, 1, 1, and 2. So this is the multiplication of relation matrix R and F. Okay, let's look at the last question. Last question. Okay, change the page. There's a question. This is the last question. Or question is explain which are given as a relational function. Write the reason. Okay, let's write relation and function. with the R. Let's look at one. Then we will continue. So for R, there is, A to B as a, alpha goes to A, beta goes to B. There is the, alpha A again, beta B. There is this psi to B and delta C and pi E. There is the only unique relation, and then we say elements of A has a unique relation set B. So we will say this is the function, and this is also relation for R and S. Let's look at the S. So what we have for S, alpha to A, beta to B, psi to B, and delta to C, pi to E, and psi A. You see psi and beta and alpha repeating more than one times as a set, first set to the relation. So we will say elements of A doesn't have a unique relation. So we will say, okay, this is the relation, but not function. And T, let's look at T. And we have, as you see here, as a T, A has a relation with X, A, Y, A, Z. In set B, elements have more than one relation to set C. So we will say this is relation, of course, but not function. And then we will say A, B. Okay, we can write D and E and E have more than one relation. If there is a unique relation, we will say this is a function. Okay, there is the X. So what is the X? Alpha has a relation with the X, beta, psi to Y, delta to T, and pi S. Okay, this is the function, also means this is the relation. So what else to our explanation? We can say alpha, beta, psi, delta, pi has, a set members, okay, have unique relation, okay, relation on set. What is the set? C. On C, and this was the X and then Q. So what is the Q? X, E, Y, D, X, Y, T, Z, S, U. Okay, there is the unique. Okay, this is set C set members have unique relation. Okay, have unique relation on set what? Set B. On B. So we know the reason, but we have to talk about R, T, and Q. Okay, R is a function. T, no, R, X, Q. R, X, Q. Okay, R, X, Q. So this is a function from A to B, right? Here is the function A to B. This is the function A to B. So this is also function, I'm sorry, we make it like that. This is the function A to C, and this is the C to B, and I'm going to look for one-to-one, onto, and last one is a immutable situation. So if I look at function R, it is from A to B. So what is the A? Okay, A to B. Alpha, beta, psi, and delta pi as a member of A. There is the set set B, A, B, C, D, and E. So what is the R? And this R, yes, alpha to A. Okay, we have alpha to A, beta B, and psi B. Okay, and delta C. Okay, C should be come to down a little bit. Okay, pi to E. So when we look at that function, this is not one-to-one because I have two B and not one-to-one, not onto. So of course, not immutable. So relation, actually it is the relation also A to C. And let's look at A to C, alpha, beta, psi, delta, pi. And what is the C? I have C set like that. X, Y, Z, T, S, U. Okay. So what is the X? Okay, alpha to X. Okay, I have that one. Beta to Z. Beta Z. And psi to Y. Psi to Y. delta t, okay, delta t, pi to s. So is it 1 to 1? Yes, but not onto, so not multiple. And last one, as a relation and function c to b. Okay, there is the c to b. So x, y, z, t, s, u. This is the c, and b, a, b, c, b, and e. So c to b. First one has a q. Where is the q? X to e. X to e. Now x to e. Y to d. Y to d. T c. Okay, T c. Z b. Z b. S a. U c is the last one. U c. So there is 1 to 1, no, because t and u goes to c. It is not 1 to 1. It is on covering the all and then not in multiple. So this is our solution. Thank you for watching, I hope. See you.